greatest common factor, or GCF for short. Now a factor is a number to be multiplied. A factor also divides another number without a remainder. Okay. Two other facts that you need to know. One is always the first factor of a number the number itself is the last factor. Okay? So if a factor is a number to be multiplied, it also divides another number without a remainder, which is called exact division. One is always the first factor of a number, and the number itself is the last factor. So let's do some examples. What is the GCF of 18 and 21? Well, let's list all the factors of 18. Okay, 1 is the first factor, and 1 is multiplied by 18. I know 2 works because 18 is an even number. 2 times 9. I know 3 works because if I add the digits of the number, and it's a product of 3. 1 plus 8 is 9, and 9 is a product of 3. So 3 and 6. And those are the factors of 18. They're the factors of 21. 1, 21. 3 works. And 7. Those are the factors of 21. Now we're going to circle what they have in common. They share 1. They share 3. And that's it. So the common factors of 18 and 21 are 1 and 3, but the GCF is 3. So if I have a group of 18 things and 21 things, 3 is the biggest number I can use to break down 18 and 21. Choose another example. Okay, what is the GCF of 20 and 25? Okay, so let's list the factors of 20. 1 times 20. It's an even number. So I have 2 times 10. 3 does not work. 4 works. 4 times 5. And those are all the factors of 20 and the factors of 25. 1 and 25. And then 5. 5 times itself. So 1, 5, and 25 are the factors of 25. So they share 1 and they also share 5. But the greatest one is 5. So the GCF is 5. Okay, now we're going to study the GCF using prime factorization. Now let's take an example. What is the GCF of 20 and 30? Now let's solve it using listing. So if I have 20, sometimes this is a little bit more tedious because you have to list all the factors. You have 1, 2, 4, 5, 10, and 20. On the factors of 30, 1, 2, 3, 5, 6, 10, 15, and 30. Now they share 1, they share 2, they share 5, and they share 10. So the GCF 10. So 10 is the biggest factor I can divide both 20 and 30. Now, this method is listing all the factors. Now, sometimes this is tedious because if we leave out a factor, we end up in problems. Now, with prime factorization, we do not have to list all the factors. So, let's do a prime factorization of 20. So we can start off with 2 times 10 and 2 times 5. And for 30, we can start off with 3 times 10. 3 is prime. And 2 times 5. Okay. Now we have 20 and 30. Twenty is equal to 2 times 2 times 5, and 30 is equal to 2 times 3 times 5. Okay, so this particular method, we're going to multiply the shared prime factors. Again, we're going to multiply the shared prime factors. So they share 2 one time, and they also share 5. So the GCF is equal to 2 times 5. Again, they share 1, 2, not 2 2s. We are just circling, they share 1 2 and 1 5, which, as we saw from the listing method, our answer was 10. All right. Let's do another example using prime factorization. What is the GCF of 18 and 27? Using prime factorization, so if you use our factor tree for 18, you can start off with 2 times 9. 2 is prime. 3 times 3. 3 is prime. 27. I have 3 times 9. 3 is prime. And 3 times 3. So I'm going to see the prime factors that they share. 18 is equal to 2 times 3 times 3. And then 27 is equal to 3 times 3 times 3. Now I look at the shared prime factors. They share one group of 3 and the second group of 3. So my GCF is equal to 3 times 3 because they share 2 3s, which is equal to 9. Okay, now we're going to study least common multiple. Now multiple a product of a number and a whole number. So, for example, if I list some multiples of 2, they are 2, right? 4, 6, 8, 10, and so on. Multiples of 3 are 3, 6, 9, 12, 15, and so on and so on. Alright? 2 times 1 is 2, 2 times 2 is 4, 2 times 3. Alright, so a number and another whole number. That's how we get multiples. Alright, this is what our times tables is based off of. Okay, let's take an example. What is the LCM of 18 and 10? Well, let's list some multiples of 18. Alright, 18 times 1 is 18. The next multiple, 18 times 2, calculated is 36. Eighteen times 3, we have 48.